Hi, welcome back to another video about Arduino and Python. And in this video, we will start to use use the board to read in the analog input from a device, and we will read in that value into the Python. So for example, in some application, we will have a sensor, and the sensor will send some data to the Arduino Uno, but we want to process the data in our computer using Python. So how can we do that? Of course, we need to use the protocol formata that we introduced in the previous video. If you haven't watched the previous video, please watch it since it's the introduction in order to how to set up the environment that we can communicate between the Arduino Uno and the Python on our computer. But in this video, we will do an application in order to demonstrate some function that we might need in the reality. So in this case, I don't have a pot meter, but somehow I have a joystick, and the joystick, to access joystick, if you can see the inside of the joystick itself, it actually consists of two potentiometer. One to track the value of the left and right, and the other potmeter is to track the value of up and down, so the joystick can give us the position in two-dimensional axis. And how to connect this joystick into our Arduino, of course I use some reference. If you want to check out the reference, please try in the description of this video. I put the reference in the description. In this case, it's quite clear according to what we have, according to the schematic of our joystick. We need to connect the 5V together because they need to be connected to 5V, so we can connect them together and then connect it to the 5V pin in our Arduino Uno. Next, we have the ground, and because the schematic ground of the joystick already connected together, so we just need to have one connection of the ground to the ground of our Arduino board. Next would be the analog input for the left and right value. So this is the first potentiometer, and for the value of this left and right potentiometer, we just need to connect to one of the analog inputs, or if you like, you can even connect to the digital input. However, I prefer to connect to the analog input since we are reading in the value of a potentiometer. And as you can know that in a normal example, when we use a potentiometer, we would like to read in the analog values rather than the digital value. So that's why I want to demonstrate the analog values. Okay, so we have the potentiometer for the left and right value connected to the analog input A1. You can connect to another analog input. However, in the code, it will be a little bit different. But in this case, let's just stick to the input pin A1, so everything can be consistent. Next, the second potentiometer indicates the value of the up and down value. Of course, we also need to connect that pin to the another analog input, which is the A0 in this case. So this is the whole connection of the potmeter to our board. I will do two examples. One example that we will read in the value of this potmeter using the Arduino platform. It means we will write the program in the Arduino platform, upload it in the memory of the Arduino, and we will see the value that the Arduino received from the joystick in the serial of the Arduino platform. So that's the first example. And the second example, which is our interest, I will use the Python on my computer and communicate with the board in order to receive the value from the joystick. Now let's move to the first example where we will use the Arduino platform. And this is the first example where we will read in the value of the joystick using the Arduino platform, program in the Arduino platform, and we will see the value read in the serial monitor of the Arduino platform. It's just like a reference for us when we start to move this program into our Python on the computer rather than uploading the program into the Arduino. So now let's go to this example. This example, you can even see that I got the reference from the read analog voltage. How to open this example? We go to File. Of course, we start the Arduino platform, the Arduino application, and then we go to Examples. And we choose analog. There will be, I think, maybe sensors, not communication, no, basics. Yes, we go to basics, and you can press on this example. And I don't know, maybe it's somewhere here already. It's not open, but we can try to open it again. Okay, it's open here because I do the modification into that example, so that's why it doesn't open another one. I would do the modification is not too much. I just change something in the serial printing so we can easily see the values when we move the joystick. And as you can see from here, because we will read in the joystick, the left and right is connected to the A1, so the A1 is here. It's left and right. Sorry, maybe we can check out the schematic from here. So the left and right is A1. Left and right is A1. We go back here. Left and right is A1. A1 is here. And it is stored in the voltage 1. Voltage 1, not 0. And the up and down will be 0. So the voltage here should be 0 when we print out the value accordingly. Now let's open the serial monitor where we can see the read-in value. We can clear the output. Okay, now let's begin. I think we can see from here. Let me upload this program into the Arduino so we can start to see the value. And we clear the output here. Okay, you can see when we don't do anything, everything somehow is in the middle because the potential meter is in the middle. So now let's move the joystick a little bit, and you can start to see the up and down change value, of course, because I just move it down. I release it and we go back to the middle point. I push it up or I push it down. The values now is low in the up and down value, and I move it a little bit too. I don't know which direction is left or right, but let's just say I move it aside. And you can see when I move it aside, the left and right value change. And I move it to another side, also the left and right value change. Okay, that's how it goes when we upload program into our Arduino, and the Arduino starts to read in the value from the joystick into the serial monitor of the Arduino platform. That's the first example, but our focus is to use the Python on our computer, interact, communicate with the Arduino to get the values that we receive from the joystick. We use this one as a reference to check how good or how accurate the code in our Python is. If it's not accurate, we start to modify it a little bit, or if the value printed out is not so good as we see in the monitor here, because in the monitor here we already do the conversion from the digital input from, like, we do some calibration. Let's say this is some calibration in order to get the correct value of the voltage happening in the joystick. So if we can see the value from here, we can use it as a reference to modify or to calibrate the value that we read in our Python. So now let's move to our main focus, which is the Python on the computer interact with the Arduino to store or to read in the value of the joystick. Okay, before moving to the second example, as you can see that the Arduino still got the old program that we uploaded, the program that we read in the joystick using the program in Arduino application. But now we want to move on to the Python. So if you have not watched the very first video introduction how to set up the environment, please watch it. In this case, I will just do the step again, but don't explain too much like in the introduction. So the first step, we need to first upload the formatter, which is the standard formatter protocol, to our Arduino. It's like a program into our Arduino, only just to make the Arduino able to communicate with our computer through the serial connector, so that we can control the Arduino using the Python code in our computer. So now let's upload the standard formatter to the Arduino so we can set up the communication on the Arduino board. And the uploading is happening. We can wait until we see all of the signal of the transmit and receive is finished. So now everything to be stable, everything is done. It means the formatter now is already uploaded into our Arduino. Now let's go to the Python on our computer. Open Spider. This is the project that we created in the very first video, so just watch it if you have not. All of the code in the Python and also the code that I used in the Arduino application previously in the first example, I put all of them in the description section of the video. Please check it out. Okay, so this is almost the same with what we have in the very first video in the introduction. The only difference is that after we got the board, connect to the board, our Arduino through the appropriate COM, through the appropriate port. Of course, how to check the port, we just need to go back to our Arduino application. We go to tools and we see port is COM11. That's why here we put COM11. And after that, because we need to read in the analog input from the Arduino, sent from is a signal sent from a device connected to the Arduino, so we need to have a infinite loop or the iterator in order to keep reading in the analog inputs of the board. And as you can see, it's quite similar to how we do things in the programming of the Arduino application. Again, we need to set up which is the pin that we read in, and the pin that we read in, the analog one, the pin analog one here, the pin analog one. Maybe it's not too easy to see, but this is like the pin analog one. And the pin analog one, according to our schematic, is the input of the left-right value, and the pin analog 0 is the analog input of the up-down value. And again, we need to have an infinite loop to read in the value, to print out the value. After we read in the value here, there will be the beginning of the process where the value is none. It's not even a value, a proper value sent by the device. Some values when maybe the protocol communication between the Python and the Arduino Uno is established. So we should ignore it, and we only read in the value when it makes sense, when it's a real value. Here I just read in the value, and then I want to check what is the type of the value that we read in through that protocol when we received from the board in our on Python and through the protocol of the formatter already established. I check it, so after that we can do some calibration in order to receive the values of the voltage really received from the joystick, just like we see in the serial monitor in the Arduino application. Now let's run this one. We run it. Okay, permission denied. To solve this case, maybe we just need to restart the kernel. To restart the kernel in Spider, you can see here in the console, a little bit on the right hand side, you choose the symbol option and we restart. And then we wait for the restarting process. Finished. Now it's finished. We can run it again. Okay, it's still denied. We just go back here, maybe upload it again. The formatter protocol. And wait for it to finish. It looks good. Go back to the Spider, restart the kernel. Restart the kernel. And we run the program. Still denied. In that case, we need to plug out and plug in our board, and we start the process again. I plug it out, now I will plug it in again. Okay, after plug it in again, of course we need to upload the I upload the wrong one. We have to upload the formatter. And again we wait patiently, we wait. Error, access denied. Opening serial port. Okay, let me reset the board and we upload again. Or we can just close this window. We close the serial monitor and let's see. Okay, done uploading, and we go back to the Spider. We restart the kernel. We wait for the restarting process to be finished, and then we upload it again. So now it runs fine, right? It runs quite fine. Okay, we can see the values here. The values of the the down value is quite in the middle, and also of the left and right values also in the middle. Since we have not moved our joystick much, now let's move the joystick and see the value how it changed. Let's move to the battery so we can easily see. Okay, now I move it totally, maybe up or down, and the value of up or down close to 1. And if we move to the other direction, the value of up or down close to 0. So the range of our values that we received in the Python is somehow from 0 to 1. Now if I move to a side, I don't know left or right, but we should see the change in the left or right value, and we do see the change. You can see it's close to 1. I move to the other direction, a side, is very close to 0. So the value that we received somehow in the range of 0 and 1. And we want to see the value close to the value that we see in the serial monitor. To do so, because we also know that the value of the value here, the left right value, have the class of float type. It's a float type. And a normal integer has the integer type. We can totally just multiply them together. To do so, I think I just need to maybe comment out those two lines and print the value here times 5, because we are in the range of 5 volt. Okay, now let's stop our current communication. And when we stop, you don't see anything changes here. If we try to run the Python code again, we will have the access denied. So the solution is to restart the kernel. Restart the kernel. Again, we wait, and now the restarting process has been finished. We run the program again, and it seems to work quite good. And then you can see that the left right value is 2.5, 2.5, very close to what we see in the serial monitor, right? So now we somehow finished the calibration in the Python in order to receive the appropriate value. And you can see we have received the appropriate value of the toy stick. So it's good. It's good. You can find the code of the Python and also the code of the Arduino application in the description section of the video. If you find the video is useful, or if you find something wrong, please give me a comment and give me a subscribe if you really feel that the video is useful. Anyhow, there are some sentences that I leave here. Those I explained in the previous video, so please watch it to understand what does it mean the body digital right 1 and the body digital right 0. Thank you so much for watching. See you in another video. Goodbye.